Bu oturumda 4 konuşma olacak. İlk konuşmayı Profesör Kavuşan Dahi yapacak. Kısaca size hakkında bahsetmek istersem, doktora derecesini 2009 yılında Kuzey Carolina Üniversitesi'nden almış. Mezuniyetinin ardından aynı üniversitede çalışmış. Ayrıca Amerika Birleşik Devletleri'nin Kaliforniya eyaletinde bulunan risk yönetimi şirketi ImageCat Introduction'da çalışma deneyimine sahip. Dr. Dai 2011 yılında Çin'in Şangay kentindeki Tongji Üniversitesi'ne doçent olarak katılmış. 2018 yılında Sichuan Üniversitesi'ne katılmadan önce Şangay'daki inşaat mühendisliğinde afet azaltımı amacıyla kurulan laboratuvarda 7 yıl boyunca görev yapmış. Şu anda Sichuan Üniversitesi'nde ulusal düzeyde seçkin profesör olarak görev yapmakta. Ayrıca Qingdao Araştırma Enstitüsü'nde dekan yardımcısı ve Hong Kong Politeknik Üniversitesi ile Sichuan Üniversitesi arasında ortak olarak kurulan Afet Yönetimi ve Yeniden Yapılanma Enstitüsü'nün Fakülte Komitesi Başkanlığı görevlerini yürütmektedir. You can start, Professor Dai.
Thank you, Chairman, and thank you very much, the organizer, the association, and also my friend, Professor Çelik, give me this opportunity to come to Turkey. This is the second time I come to Turkey, but the first time to the Izmir. And it's my honor to present some of the work we did with my student and for the composite slab and use the precursor concrete. But before I start, I just let you know the detail of my city and my university. You can see the map of Chinese earthquake record here, and our city, what we call Chengdu, our university located in that, it's one of the largest city also in China, but we are very seismic active zone in China. It's very similar to Turkey, and if all your professor or the expert do something related to earthquake, you may know this 2008 Wenchuan earthquake. It's very close to our city, and the city, Chengdu, is the capital of Sichuan province. It's where the earthquake occurred in 2008. And after 2008, actually every 2 or 3 years we have big earthquake. So that's a problem for us. But there's still some beauties of the city. And if you love panda, and all the panda in the world probably were born and raised there and then sent to different places of the world. And so we are the city of the panda. And there's pretty much very good spicy food, hot pot. Professor said it with us before he tried. And you are also welcome. If you have a chance to let me know, I can invite you to come to our city and to see the panda and to try the spicy food, okay? My presentation will be this 4-part for the background, and since it is the first time I present in Turkey, I give a little bit, the research related to precursor concrete in China and engineering practice, and then I'll go to the details of what we did with my student, and also some engineering applications for our technology. And at the end will be a concluding remark. And so you can see from the figure, this is the recent 5 years and the trend of the precursor concrete market. But actually this technology we had before in 1970s or 80s for the precursor concrete technology. At that time it was very popular. But after 1976, there's another big earthquake occurring in China. It's in the coast, in the eastern part of China, and we call it Tangshan earthquake. After that, the precursor concrete, stopped for 20 or 30 years. And after 1990s or around 2000, and precast concrete and became popular again. So different university professors and started this work, and this is what we use now and in China primarily for the floors and sometimes for use for the walls and the stairs. This is widely adopted for the residential construction. But for the column and beam and also shear walls, all this structural element, depending on what kind of city or the region, and the percentage, whether we use that, will be different policy of different city. And for the market, you can see here is a prediction and for the residential industrial construction using the prefabricated concrete, and I think it's still increasing, but the current situation in China is our engineering project going down a little bit, and this is a very good trend to see will still widely use precast concrete. And this is a statistic about prefabricated concrete and steel and timber for the structure types and using different material in China. And you can definitely see the dominant still the concrete one. Still, we are increasing the number of steel structure, but still compared to the concrete, still expensive in China, and that's why we use concrete. And also, if you compare that with the material itself, okay, the primary or the very dominant go almost 60% will be the concrete material instead of purely steel structure or glass or timber or the rest of the material. And this is some pictures I got from the construction site. One of the reasons in China we use this prefabricated or precast concrete, which the number of the labor or the population, also, it's going down. And now the young generation, they don't want to work on site, and there's one of the reasons. And we have this policy, and this is one of the biggest, government supported project at Shenzhen. It's the south part of China. It's where we call it. It's also very economic active city in China, and that's why it's almost 1.15 million square meter for the floor area for this individual project. It's a government supported and project, and the apartment will be rent for those young people who work or in this city and with very low rental fees, and try to support them can settle down in Shenzhen. Okay. Also for the technology trend, and currently for the engineering company, they promote from purely prefabricated concrete and try to use the beam technology or MEP, all this technology they adopt in their real project. And for the earthquake-prone region, as several speakers already mentioned, we also use some dampers, try to help the seismic performance of the concrete structure. This is one of the type of damper study in China, and that's between the different walls, or you can put what other speakers already mentioned, at the big column connection, you can use different dampers, friction energy damper. Sometimes they also use the self-centering system and a different structure system. So the technology is still advancing. So this is one of the projects at Shanghai. Of course, Shanghai is not that active for the earthquake itself, but sometimes for the very critical or like a school or hospital buildings, the government still suggests probably you can use dampers to help the protect the buildings from possible earthquakes. So this is one of the projects there. And another project they use dampers is in my city, Chengdu. Is as I said, it's a very active earthquake-prone region, and this project, actually saved the investment if in this high-intensity earthquake regions. And you can see here, dampers dissipated over 20 seismic energy. And besides the buildings, actually prefabricated concrete used widely for the transportation infrastructure, especially the bridges, like very busy, road, and especially in the cities, they use this technology to accelerate the construction on site. And you can see the picture there, and they also use for the girders, or they save the time for the construction of the bridges. And as I said, this is very popular in China for the city road, and they will shorten the construction time. And this is south part of China cities, Guangxi, and they also use that for the port. And the reason is also they can save some labors, and also they use this type of heavy crane, and the component of the precast concrete can be heavy. I have been working in the renewable energy infrastructure since I came back from US and joined Tongji University in China in 2011. Actually, in that year, China, become the number one in the world for the wind energy or wind power installation. And until now, this is a report from the Global Wind Report last year. And you can see from this figure, both onshore and offshore wind energy, and China almost have half of the world capacity. And I studied this type of structure, at the beginning it's a steel tubular structure. And currently, as you can see from this figure, concrete tower almost have the comparable market compared to the steel tower. The reason is the concrete tower is very cost effective. That means it's very cheap, and compared to the steel in China. And so when the building market for the precast concrete going down a little bit, a lot of manufacturers, they switch to this type of renewable energy infrastructure. And so their factory can still be fully operated, but the product will be like this, okay? So for the wind turbine tower, usually they'll have concrete at the bottom, almost 2/3 of the length of the tower, and at the very top they'll keep the steel. And then between the steel and the concrete, there's a connection between them. And you can see from this figure, and the construction still uses a crane. And this is a manufacturer or factory place. And some of the company, usually the previous product is for the metro line tunnel and the line, but with this requirement going down in China for the metro line construction, they also use a different mode and then try to manufacture to produce this wind turbine segment, concrete segment. And this is transportation and also the construction on the site. And at the very beginning, this technology, I think, originally from a European country like Spain or some place, but China right now, they develop, at least 10 type of structural system for wind turbine, for the concrete part. And they mostly will be like precast and pre-stressed. This is on-site assembling steps. Usually first you have foundation, and then you lift and use the crane for the concrete part, and then the steel part, and finally will be your turbine machine, hub, and the blade. Okay. At the very beginning, the tower concrete part is not that kind of circle. It's rectangular at the beginning. This is one of the first. At 2018, this is the 120-meter tall at the hub. Well, the hub means from the bottom foundation until the turbine machine itself there. Okay, so 2008, this is one of the tallest at 2008. But you can see the cross section of the tower is not a circle; it's rectangular, and with that, and a different company developed their own structural system, and this is one of the project with 32 turbine in one wind farm with 140-meter tall hub height, and the tallest one currently in China. This is last year. We have the 200-meter, hub height, and this is the tallest currently in China. Actually, between the conference at the break, I contact one of the biggest wind turbine manufacturer. Goldwind is #1 in the world. It's Chinese owned company, and they actually got 2 contracts in Turkey, and they'll start one of the blade manufacturer or factory in Izmir, I think in 2027. And so this is one of the structure actually I have been working on for like more than 14 years. And also for this 200-meter tower, they also have some AI-powered defection recognition used the drone. Besides the tower, we also use precast concrete for the foundation of the tower, especially for the brace and part. You can see here. And usually all this brace is prefabricated, but the bottom is still the cast on site and for the concrete, and then they assemble together, and then they use the soil, and so to save the concrete for this part, they use the soil as the self-weight. Okay, so as I said, the precast concrete technology in China, and we have been developed rapidly since 2000. And of course, the start will be the buildings, and then we use widely in bridges, port, and different structures. And currently, the big market also for the renewable energy, especially for the wind turbine. And so I think probably we can communicate a little bit more and after the presentation, because the Goldwind told me they have probably will use concrete tower also. They'll try this in Turkey, but I told them this very seismic active region will be very careful about the connections of the different segments. Yeah. Okay, let me go to the one of the experiment I did with my student, and this is one of our industry partner. They raised the issue because at those buildings, and one of the problem for the different part put together is usually they leave this kind of extended bars for the floors or for the beam column connections. One of the problem for them, they told me, is for the transportation. Usually during the transportation, and probably they'll some of these extended bars will be bent or will be hit and will be complicated for transportation. So we think about use different things, and whether we don't need all these extended bars, and either for the bolted connection or lap slice the rebar, and one is for the to connect all these floor slabs, precast slabs. And to study this, we propose this beam to slab joint. We use the L-shaped groove, and also we lap slice rebars for those precast slabs. And during the simulation or during the preliminary discussion, we think should be safe. The difficulty they'll meet during the transportation and the construction. So to validate the concept, we work together to do a full-scale testing to see the performance. If we use this kind of connection compared to the traditional, you have extended rebar, and will be an change of the structural performance. So this is how we construct all these slabs, and then we do the full-scale testing, use the the heavy concrete block, and to simulate all the loading. And this is one group of the testing specimen, and it's 3.5 meters long and 1.8 meters wide, and the thickness of the slab is 130 millimeters. And of course, we have three different types. One is we use our technology. Another one is you have still keep the extended bar. And the third one, for the comparison, we have cast in place, slab. And this is a measurement plan for the deflection and strain gauge. And this is the result during the loading for different specimens. This is one group, and we have three different groups with three different dimensions. And this is a correct pattern during the loading or after loading. And actually, we in the test we put it pretty a little bit high so we can go downstairs to observe the crack development. And for the crack pattern, we compare our proposed connection with type of slabs with the traditional one and also the cast in place one. And there's no big change. And of course, based on this experiment, we try to build a numerical model and to be verified by the experimental result, and then we do some parametric study and to see how long can be the L-shaped groove, or how long will be those carting and all this. And after all this study, we propose this design method. And especially here we have the for the L-shaped bars, we propose its space for the intervals, and also for the groove, how the size and also the depth of the groove, and all these things. And through this experimental and numerical work. And of course, this is a slab. Also, we propose a similar thing for the column and beam connection. And due to the time reason, I will not introduce the detail of the column and the beam connection. Let me go to the engineering application for this technology. As I said, besides the slab, we also propose a similar connection system for the beam and the column. We also did some lab testing and also numerical work. And with all this, actually, we use all the technology have been adopted in different real engineering projects. This is one of the projects also in Shanghai. And is the total gross area is pretty big, but this is a school building. And another one is also in Shanghai. And this one is office building, and we use our technology and for both beam column connection and for our new proposed technology, and also for the floor connections. This one, and also in the group of these buildings that they have together, we use our beam column connection for this project as well. And so I think besides Shanghai, we also use that in Chengdu, that in Sichuan as well. But as I said at the beginning, different cities of China have a different precast requirement ratio. Like the biggest city in Shanghai, the ratio is higher than in Chengdu. That's why there's many more projects there and compared to Chengdu. Okay, let me keep short for the conclusion, and I just present a little bit of the precast concrete technology we use in China for, of course, the residential and the industrial buildings, but I also introduced the bridges, especially the wind turbine tower. We use precast concrete tower structure widely now in China compared to the steel. But for the specific research we did, we use the L groove with L-shaped rebar and propose this connection for the slabs and also the beam and column and connections. We did some full-scale testing to validate this concept, and we did some numerical work and for the parametric study, and we proposed the design procedure or design guideline for this type of connection. That's what I have. Thank you so much. and I appreciate to be here to present. Thank you.
Thank you so much for your presentation, Dr. Bai.